Canon says the C stands for cinema. I say the C stands for complicated. What's up everybody, I'm Jason and welcome back to some more tips and tricks for the Canon EOS R5C. So if you follow along with the channel and have been following along with my EOS R5 videos, I recently did a couple of videos looking at the audio capabilities when shooting video on the EOS R5, and that was super easy. There's only 2 audio inputs on the camera, and there's literally only 5 settings that you have on the camera to deal with. The R5C, well, that's not quite the case. So instead of just having 2 videos like I did with the other one where I talked about everything on the camera and then did some performance testing, this is actually going to end up being 3 videos to keep everything in a reasonable amount of time. That's how much more complex the camera ends up being. So in this video, we're going to talk about the inputs, how to get audio into your camera. We're going to talk about the formats that the camera can record in and how you go about doing that. And we're going to talk about routing, how the camera deals with basically sending audio from the various inputs to the various outputs that it has available to it. Next time, we will look at the settings that control all of this, so I'm not going to get into settings. This is going to be more of a high-level kind of technical talk or technical look at the camera's capabilities. And then in the final part, we will actually do pretty much the same performance testing that I did with the R5, only we'll be doing it with the R5C to see how it stacks up. So with that said, let's get this show on the road, and let's start by talking about inputs, how to get sound into the camera. Now, on the R5C, there's actually 3 different inputs that you have available for you to get audio into your camera. The built-in mic, Canon calls this the monaural microphone in the manual and documentation. I'm going to be calling it the built-in mic because it is the microphone that's built into the camera. The microphone input and the multifunction shoe. So, starting with the built-in mic, this is basically the same microphone as is in the R5. It's a little embedded kind of on-circuit kind of microphone like you might expect from, say, a smartphone or integrated into a camera. It's located in the same place as it is on the R5, so if you're looking for it, it's the little hole in the front of the plastic housing or material that's between or next to the autofocus light between the hand grip and the viewfinder housing or the lens mount. So if you happen to have your finger over that while you are shooting, you will end up muting out the microphone's recording quality. Now, as the manual suggests by calling it the monaural microphone, this is a mono-only input. There are no multiple, or there is no other microphone on the camera making it stereo capable. And on top of that, given the size, there's not a lot we can expect from this in terms of quality, so not professional audio. Where the built-in mic on the R5C differs significantly from the built-in mic on the EOS R5 is that this is auto only. We have 0 control over the microphone. In fact, when the camera released, we couldn't even turn it off. That was added in firmware version 1.0.2.1. So if you're in the audio menus, which we'll talk about in the next video, and you're looking for why can't you turn off the built-in monaural microphone, yeah, it's because you have to upgrade your firmware to even get to that capability. So this is an auto microphone or auto levels only, auto gain control, whatever you want to call it. There is no filtering or attenuation capabilities. So like on the R5, you could turn on a wind filter, you could attenuate the built-in microphone. None of that applies here. So we have very little control over the dynamics of your recordings if you happen to be using the built-in mic, which quite honestly makes this somewhat less useful than the microphone in the EOS R5. You have control over that built-in mic while you don't have here. So even though you're not going to get the greatest quality sound out of the built-in mic, at least on the R5, you can tune it a little bit. So with that said, what is this mic good for? Well, obviously it is a mic, and if you are doing vlog style shooting, say at arm length, it can be passable. But I find even that is a bit iffy because you can get wind noise from moving the camera or fans, air conditioner vents, all of that kind of thing can end up causing wind noise in your video. So If you want to see what that looks like, this is what it sounds like when I demoed it. Hey, what's up everybody? This is Jason. I'm shooting this vlog style on an R5C, so kind of at arm's length, wide angle, but this is to give you an idea what the audio sounds like from the built-in microphone. Yeah, not really that good, and you can hear that wind noise, and I'm in an indoor room with a ceiling fan, so not ideal. Where this microphone, I think, really shines, for lack of a better word, where its really use is if you are doing two-system audio, you can use the built-in microphone to record a sync track that you can then use your NLE, so Premiere, Resolve, etc., to resync the audio with two-system audio in post. Now, the R5C does make timecode synchronization considerably easier, but there is an added cost, there is an added level of complexity, and, you know, if you can just do it in the environment you're working in with the audio sync, the waveform sync, then the built-in audio or microphone is good enough for that. Now, if you're wondering what that sounds like, I have my camera about 10 feet, or about 6 or 7 feet away from me, so a little under 2 meters-ish, and this is basically the audio that you're hearing from the built-in mic. So again, not really good, but good enough for most NLEs to actually do synchronization with. Your second audio input is the 3.5mm mic terminal. So this, again, follows pretty much everything that you have laid out on the R5 here on the R5C. So if you look on the connectors or ports side of the camera, where all of the plugs are under their dust covers, this will be in the frontmost column at the very top. It's labeled mic, and it's a 3.5mm or 1/8 inch tip ring shield or mini headphone style connector. It provides 2 channels of unbalanced audio, so this is not XLR. It is not any way capable of dealing with XLR mics. It does provide plug-in power, so this is 2.5 to 5 volts of power for consumer-level condenser microphones, that kind of thing. But beyond that, we aren't talking about anything especially impressive, which, considering that Canon did have to rework parts of the camera for, say, the timecode input and, you know, removing the image stabilizer from the sensor, you know, they could have provided an XLR-ish connection here. The XLR only requires 3 conductors. There's 3 conductors here. So they, in theory, could have provided a single mono or a single channel XLR connection. Sure, you'd need an adapter, but they didn't do that. So we are stuck with what we have. Additionally, this is a mic level input only, so you cannot switch a setting in the menu and get line level inputs if you want to hook your camera up to an audio recorder or a mixing board or something like that. You will need to have a 40 to 50 decibel pad cable to bring that down to a signal level that the camera can deal with. Now, there is attenuation on this input, but it is only 20 decibels, which is not enough to make up for the extra loudness that you have in a line level connection. So what is this good for? Well, basically, this is where you hook up your entry-level on-camera mics. So your Rode video mics, your Sennheiser, Deity, etc., equivalents of those, or your wireless mics, the entry-level wireless mics like Rode's Wireless Go or DJI's wireless mic system. Incidentally, this is what it sounds like with a Rode video mic, so the quality here is going to be a little bit different depending on the mic that you have, but again, at 7-ish feet or 2-ish meters away from the camera, again, it's going to be a little thin, it's going to sound a little far away, but, you know, it is there and it is an option that you have. Now, the final option on the R5C is the multifunction shoe, and this has the promise to be by far the most capable feature of the camera or function of the camera. You can certainly get potentially the best quality audio into the camera through this system. Where the multifunction shoe really falls down is that it is not being widely pushed by Canon. Yes, they are putting it in basically all of their cameras at this point, but they are not actively or significantly seeking third-party support and implementations using this. So as the current market stands, there's really only 2 devices that can use the multifunction shoe. So now why do I say that this is potentially the best quality audio that you can feed into your camera? Well, that comes down to the fact that the two audio channels that you do get from the Multifunction shoe are digital, which means that the analog to DC or analog to digital conversion and the amplification that is being done to your microphone source has to be done outside of the camera in the interface that is hooked up to the camera, and the connection between the interface and the camera is digital, so it's not subject to analog interference. What this ultimately means is that third-party analog to digital converters or audio interfaces that use the Multifunction shoe can use much better amplifiers, much better analog to digital converters, much better power filtering, etc., than what Canon has built into the camera. Now, the Multifunction shoe supports, as far as I can tell, up to 24-bit audio. At least that's the limit as of now with the devices that are currently on the market. Who knows if that's the maximum limit? It may be able to do 32-bit floating point audio, but nobody out there who does 32-bit audio is actually building a Multifunction shoe interface for Canon's cameras, so who knows? Sample rate is, again, 48 kilohertz. It's the same sample rate that the camera uses everywhere else. Again, this is dictated by the external device, but there appears to be some possible configuration options involved here. When push comes to shove, the Multifunction shoe could be really incredible. Unfortunately, as the situation is right now, there's so little information on it that we really don't know what the capabilities are beyond the basic marketing and limited specifications for the few products that actually use it. So what are those two products that actually use it? Well, one is Canon's DM-E1D microphone, and this is a $300 on-camera microphone. It's basically a entry-level style vlogger kind of microphone. It has one interesting feature in that its polar pattern can be adjusted from being shotgun to being stereo with a 120-degree angle of coverage or whatever. We'll talk about how that gets done because it's done electronically through the menus in the camera, but we'll talk about that next time. Now, the other device that's available for it, and probably, in my opinion, the more interesting of these two, is Tascam's CA XLR-D2 or XLR2D-C audio interface. So this is $500, which is kind of pricey, but this provides two XLR inputs, a stereo mini-phone input. It has phantom power for the XLRs. It has line level inputs, attenuation or padding. It takes care of the whole shoot and match of being a serious professional interface. On the plus side, Tascam was smart enough in designing this that if you change platforms, you can take it with you. So that is the three ways to get audio into the R5. So the camera can record in two different formats depending on what format of video you're recording and what you select in some cases. These are LPCM or linear pulse code modulated audio. This is uncompressed audio, so this is the best quality that you can get out of the camera. Or AAC, the Advanced Audio Coding Compression algorithm. It's lossy, and it's basically the replacement for MP3s in the modern era. So those are your two formats. Now, how you can choose or what formats you have available to you depends entirely upon the video format that you're actually recording in. So if you're recording in either RAW or XFAVC on the camera, then you will only be able to record 4-channel, 24-bit, 48 kilohertz LPCM audio. That's it. No other choices. You can't even turn off channels if you don't want them. If you were shooting in MP4 for your primary format, you have a choice. You can either record 4-channel, 16-bit, 48 kilohertz LPCM audio, or 2-channel 48 kilohertz AAC audio that targets a bitrate of 256 kilobits per second. So you have a choice in that. We'll talk about setting this in the next video. The final option or final situation is when you record proxy clips on the camera, so proxy files for the primary clips like you might want to do if you're shooting at, say, 4K XFAVC or 8K RAW, then that automatically records in 2-channel 48 kilohertz AAC, again, targeting 256 kilobits per second. Now, for the LPCM formats, the 16-bit format that you have when you were shooting an MP4, you end up recording about 3 megabits worth a second of audio information. The 24-bit format that you have with XFAVC and RAW records about 4.5 megabits per second of information. With respect to AAC, again, it's 256 kilobits across the board. Now, there is one other audio format that's available that's not, strictly speaking, an audio format for your recording, and this is second card audio. So with second card audio, you can record a second audio track. It's, quote, lightweight, unquote, that is separate from the audio that's recorded in the video. So when you enable this, the camera will record your video with the full audio quality audio tracks on it, as well as a second audio track on your other card that is like stripped down and compressed to sort of bare bones levels. So when you do this, you do get an LPCM file, which in theory sounds great. It, however, is only 16-bit. Its only sample rate, or its sample rate, is only 8 kilohertz, which completely decimates, for lack of a better word, the audio quality. It's really only going to be good for voice, and then really not in a huge, in a really high fidelity context. It's one channel only. So it takes all of the audio tracks that the camera is recording and down mixes that into a single channel. Now, this file is relatively small. It's only 128 kilobits per second worth of data, and it is separate from the regular audio that you are recording. So you might be asking, if you aren't already using this, why would I want to use this? And the answer is, this is a niche feature. Most likely, at least as I see this, this was envisioned for photojournalists to be able to record an audio track that was small, that's already separated from the video tracks, that would be easy to upload to your editor immediately after the interview. Aside from that, there is basically no good reason that I can see to use second card audio at all. Now, if you're wondering what it sounds like, this is an example of what second card audio sounds like in the scope of a recording. So again, pretty limited. Now, the last thing I want to talk about in this video is routing. So we have all of these inputs. We have up to 4 channels of outputs. We have different outputs. So there's the video, there's the headphone jack, there's the HDMI connection. How is all of this stuff routed? Well, there's essentially a 2-tier approach that's done with this in the camera. Now, if you're familiar with reasonably high-end audio interfaces, usually there is a menu in there somewhere that allows you to configure the routing. You can go in, you can say, I want channels 1 and 2 to be treated as a stereo pair. I want 3 to only be recorded to the card. I don't care if it does anything else. I want 4 to be, whatever, etc. That is not the case on the EOS R5C. Instead, Canon has set up static routing process in the software from the factory, and you can't change it. Now, the way they've gone about doing this is they basically assign the lowest channels and the 4 possible channels worth of audio on the camera to the highest quality or priority device. So you can think of it as being priority or optimized or priority routing. The highest priority device on the camera is the multifunction shoe. Next up is the mic input, and then at the bottom of the list is the built-in mic. So if you have something in the multifunction shoe and you have the mic input connected, that will be the only thing that the camera can record. 4 channels total that it can deal with, the built-in mic. It doesn't matter if it's enabled, disabled, whatever, the camera will only deal with the multifunction shoe and the mic input. On top of that, it will assign the multifunction shoe to channels 1 and 2, and it will assign the mic input to channels 3 and 4, assuming that you are recording in LPCM quality audio. That's the only time the camera really does 4 channels worth of data. If you don't have something in the mic input, then you're going to be 1 and 2 is the multifunction shoe, 3 and 4 is the built-in mic. Likewise, if you don't have anything in the multifunction shoe, but the mic input is connected, then 1 and 2 will be the mic input, and 3 and 4 will be the built-in mic. And finally, if none of the higher-end inputs are connected, only the built-in mic is on the camera will duplicate the mono built-in mic signal 4 times, filling up all 4 channels. Now, this isn't necessarily a huge deal, especially if you're shooting RAW or XFAVC video, but keep in mind that if you're shooting 1080p HEVC quality video or AVC quality video, the 4-channel audio accounts for somewhere around 10% more data being recorded than just the video itself. So you might want to consider that when you're dealing with your options. Now, if you have the camera set up to record AAC, then it only deals with 2 channels. Basically taking the multifunction shoe, if that's what's there, the mic input, if there's nothing higher priority, so the multifunction shoe isn't available, and the built-in mic if neither the multifunction shoe or mic input are connected. Now, I make a point about talking about 4 channels and all of these channels because that's essentially the first stage to the audio routing on the camera. Those are also the audio channels that are going to be written to your files when you record in either LPCM or AAC quality. However, the camera then has the option to deal with routing the channels or the audio to the 2 other outputs on the camera, the headphone jack and the HDMI cable. Now, in the case of the headphone jack, the camera offers a pretty significant selection of choices for what you can route. So basically breaks down into 3 major modes of operation. There's stereo mix mode, where the camera will pick 2 channels and then route them to your headphones, 1 to the left, 1 to the right. So for example, channel 1 could be left, channel 2 could be right, or channel 3 could be left, channel 4 could be right, or channel 1 could be left and channel 3 could be right, or channel 2 could be left or channel 4 could be right. It's not entirely arbitrary. You can't specify things just as you want. Those are the only 4 options that are available, but they kind of cover most of the bases. The second option is a straight mono mix. So the channel that you select, 1, 2, 3, or 4, is sent to both the left and right headphone outputs. The final option, and pretty much the only way you can monitor all 4 channels on the camera simultaneously, is through the mono stereo mixdown solution. So what this does is you can either have it take channel 1 and 2, mix that down into a single output channel, and then send that to both your left and right headphone speakers. You can do the same thing with channels 3 and 4, so that gets those 2 channels mixed down to a single mono channel and then our output, and then sent to your left and right headphone speakers. Or, and this is how you monitor all of the channels sort of simultaneously, you can have channels 1 and 3 be mixed down together and sent to your left headphone speaker, and 2 and 4 mixed together and sent to your right headphone speaker. Now, if all of this seems like it's confusing, it is. I get it. I still don't quite understand why Canon had to make the complexity here and why they couldn't just have made this like pick what channel you want routed where, but it is what Canon did. So if it sounds complicated and confusing, I get it, because I think it is too. Now, HDMI audio output routing is way easier. You only have 2 options. You can either send channel 1 and 2 to the HDMI port or channel 3 and 4 to the HDMI port. So with that said, I'm going to wrap up the formats, inputs, and routing section of this discussion here. Next time, we will talk about all of the menu settings that affect audio on the camera, and like I said, it's way more complicated than it was on the R5. And then in the final part, we'll talk about some performance testing with the camera. So I hope you found this useful. If you did, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. And as always, thanks for watching, and I'll see you next time.